Hey guys, quick little video here. I'm going to show you how to graph logarithms um, with transformations. So the last video we did, we just graphed some basic logarithms, but they're all kind of what you call parent functions, no shifts or stretches or anything like that. So I'm going to show you a couple different ways you could graph a function, maybe something like this. Okay, so um, first way you could do this, I mean, you could simply make like a little XY chart and plug some X values in and get some Y values out. But unless you have some really good foresight, that might be kind of hard to do. I'll give you an example. So you see this is a log base too. So anything right here, if you want it to be nice and neat, needs to be some sort of power of 2. So I'll give you an example. Let's say I take this X value and I'm going to put a 5 in there. I'll show you why. If I were to put a 5 in there, well, 5 minus 1 is 4. Log base 2 of 4 would be 2. 2 plus 3 would be 5. And you could kind of do that, but I mean, you'd have to be kind of good to do that. But a couple ways you could graph this. First off, if you wanted to put this in your calculator, you'd have to do something like this. You'd have to say y equals log of the big part divided by log of the base plus 3. So you could actually, you could do this. Remember, change of base says you got to do log of the big one over log of the small one, right? You could do that if you want to, but a couple different ways you could do this. What I recommend is you kind of base it off of the domain. Okay. Now, if you remember the domain for the last graphs, they were always like x is greater than 0, right? But this is going to be the key part to the domain right here, right? Remember these values right here, the quote unquote answers to the logarithm, they can never be negative. So if you ever want the domain of one of these graphs, all you got to do is take this part right here, the part behind the logarithm, and say, okay, Mr. Winslow told us that this quote unquote answer can never be negative. So you just kind of do something like this, okay? So once you do that and you add a 1 to both sides, you get x has to be greater than 1. So basically, that's your domain, okay? X is greater than 1. Now, not only is that your domain, but that'll kind of be your asymptote as well, okay? So what I'm going to do real quick is I'm just going to take a minute, and since I know the domain here is basically from 1 to infinity, right? Here's what I know, okay? I know that the asymptote is going to be at 1. Okay, basically x equals 1. Okay, so I'm going to go ahead and draw that. Now, I also know that the range is going to be all real numbers. We know that based on yesterday's homework that basically all these graphs, these logarithm graph have a domain of all real numbers. So here's what I'm going to do, okay? So I know I need to be greater than 1. I can use some foresight, you know what I mean, to kind of get powers of 2, but I'm going to just start with this first number I see that's greater than 1, the first whole integer, okay? So the first number I see is 2. So if I put in a 2 right here, okay? Let's try this out. 2 minus 1 is 1. What's log base 2 of 1? Well, log base 2 of 1, what power of 2 gets you 1? What? 0, and 0 plus 3 would be 3. So basically, the 0.23 would be on the graph. Okay. Well, what if I put in a 3 for the x? Okay, well, 3 minus 1 is 2. Log base 2 of 2 is 1. 1 plus 3 would be 4. So the 0.34 would be on the graph, right? Now you could put in a 4, but it's not going to be easy. But remember that point we did a minute ago, the 5. 5 minus 1 is 4. Log base 2 of 4 is 2. 2 plus 3 is 5, so 5, 5. And if you kept going, you kind of know the shape of this graph is going to kind of go up like that. Okay? And there's your graph. Okay? Notice that the parent function is log base 2 of x, and it got shifted right 1 up 3, right? So all these points that would have been on the parent graph, they went right 1 up 3, okay? But the main thing you need to know is this thing right here is going to not only affect the domain, but also the asymptote, right? So you can see that asymptote there at x equals 1. Okay, so I'd like to show you something real quick, kind of an alternate way you could do this. Some people like this, some people don't. It's up to you. Like having choices. So some people, remember on the last video I said some people don't like the logarithms, they'd rather deal with exponential. So I want to tell you something. You could change this to an exponential function if you wanted to, okay? So what you could do in this situation is you could simply, okay, so say I want to kind of write this as an exponential function. You could, watch this, subtract the 3. Okay, so you could say y minus 3 equals log base 2 x minus 1, like that. At this point, you could change it to an exponential, so you could say 2 to the y minus 3 equals x minus 1, like that. If you wanted to, you could add the 1. So look, you could add the 1 and say 2 to y minus 3 plus 1 equals x. Okay, now the benefit of this is you could simply just plug in y values, whatever y value you want, and get out x values. Okay, so if you made a little table over here, you'll see a lot of the same points that we had a minute ago come up. So pick any y value you want. It doesn't matter. So say I pick like a 5 for y. Okay, so I'm just going to put a 5 in for y. You put any number you want, okay? Now follow with me here, okay? So you come over here, you put a 5 in. 5 minus 3 is 2. 2 squared is 4 plus 1 is 5. So you put a 5 in, you get a 5 out, just like you said a minute ago, right? Put any number you want in, okay? I mean, you could put, I mean, if you wanted to, you could put like a, I don't know, a 7 in there. You want to put a 7 in? Follow along with me. 7 minus 3 is 4. 2 to the 4th is 16 plus 1 is 17. So you could have 17 right there if you wanted to, right? If you come back up here, check it out. 17 minus 1 is 16. Log base 2 of 16 is 4. 4 plus 3 is 7. Okay, so you could get as many points as you want. I mean, you could even put in like a, I don't know, say you put in like a 0 for y, right? What's 0 minus 3? Well, it's negative 3. 2 to the negative 3 would be 1/8. 1 plus 1/8 would be 1 and 1/8. And you can see that you're kind of approaching that asymptote of that x equals 1, right? That you can never get past. So if you want to do it like that, you can. But basically, what you need to know about this graph is that it's going to look very similar to the regular just logarithmic graph, but you can see they got shifted right 1 and up 3, right? So all those different ways you could do that, you could graph it. So let me do one more here. Let's see what we can come up with. So I'm going to say y equals, I don't know, negative log x plus 1, something like that. Okay, so what would happen here is basically from your logarithmic graph, this would reflect it over the x-axis, the vertical reflection, and this right here would shift it up 1 right now. With that base of 10, you're welcome to do this however you want. I mean, you could just think of some xy coordinates if you want to. Like I would probably just put in like a 10, like that. Log of 10 would be 1. That'd make it negative. Negative 1 plus 1 would be 0, right? You could even put in a 1 right there. Log 1 would be 0. That'd be a 1, right? Okay. You could even put in like 100 here, right? Say you put in 100 for x. Okay, well, log 100 is 2. Okay. Negative 2 plus 1 would be negative 1. So just a couple of points. And you'll notice since it didn't get shifted anywhere left or right, the asymptote is still at 0, right? But notice what happens here, okay? So watch this. If I graph this a couple points, so let's say I graph 1, 1, right? There's 1, 1. 10, 0, 2, 3, 4, 5, 6, 7, 8, 9, 10, 0, right? 10, 0. Then 100, negative 1 would be like way over here. But what you'll notice is see how it kind of got flipped upside down, right? The negative flips it upside down and then it got shifted up 1, right? So you have this graph, you still have the asymptote. I mean, you could plug in whatever. But yeah, that's kind of what the graph looks like. Okay, and you could graph that pretty easy on the calculator because it's already base 10. But remember, you could also, if you didn't want to, if you didn't want to mess with the logarithms, you could look, subtract this one over. Right, subtract the one, so you get y minus 1 equals negative log x. Okay, divide everything by -1. So if you divide this all by -1, this all by -1, you get negative y plus 1 equals log x. And then you could simply change that into exponential. So the base here is 10 to the negative y plus 1 equals x. You might say, well, why am I doing that again? Well, this way you could just simply plug in y's and get out x's, right? Plug in a y, get out an x. Okay. So remember this point 1, 1 right here? If you plug in a 1 for y, -1 plus 1 is 0, 10 to the 0 would be 1. You can still see you still get those same points, right? So it's kind of the same as yesterday, but just with some transformations. So I'll give you a little bit of practice on this and some answers, but this would be graphing logarithms with transformations. And the biggest thing you want to do is kind of look for that domain, find your asymptote, and then based on the shape of the graph and everything, you just plug in some x's, get out some y's, or you go exponential and plug in y's and get out x's. Either way you want to do it. So hope this helps, and hope you enjoy the rest of your day. Y'all take it easy.